teachers today. Do you like teachers teaching like machines or creative and humorous ones who make learning science and mathematics fun and meaningful? Of course, everybody likes the latter. One such person is Dr. Janchai, who thinks that the real purpose of education is to teach how to think. He is currently a Deputy Director of International College Swan Sunanda Rajbath in Bangkok, Thailand. He was the head of the Physics Department and the Assistant Director of the Institute for Promotion of Teaching Science and Technology in Bangkok. As an educationalist, he is the President of the International Council of Associations for Science Education. He is also particularly interested in teaching science and mathematics with toys and hands-on activities. He is also an international speaker in science education who has been invited to many conferences as a keynote speaker. He set up extremely innovative workshops in India, UK, USA, Saudi Arabia, and many other countries. He won the National Science Project Competition of Thailand in 1972 and also received an award from the King of Thailand as an outstanding researcher in 1982. It's our pleasure to have such a renowned scholar among us today. Please put your hands together as we welcome Dr. Janchai, Deputy Director of International College, Bangkok, Thailand, to come and take a seat in the dais.
First of all, I would like to express my special thanks to my old friend, Prakash. Actually, not old, he's a long-time friend. Well, today my talk is going to be on explaining science and math at home. Apart from learning math and science in school, you can do some interesting thing at home. How to do that? We have to have active learning. Sometimes the book is very boring. You read the book and this and that. How to make it in active learning? Yes, I want to do it. Just like Jimmy Wong did. It's not in the textbook. It's somewhere around you. And not only that, from normal textbook, sometimes it's very boring. You have picture like this. Picture sometimes is boring. You have to make it more interactive book like this. From normal picture, you can make like a video. So it's more interesting. Or maybe you can put the Einstein picture and Einstein can speak to you. This is more interesting. Why do we have to do this? Why? Because we can arouse curiosity. Oh, this is very interesting. Just like Jimmy Wong said, you have to be curious. And another thing is that you have to be, sometimes you get inspiration. Oh, yes, I think I can do it. It's very simple. And another thing is that you can have a better understanding. Nowadays, the people, maybe you know that about QR code. QR code is everywhere. QR code is the way it's abbreviation from a quick response code from Japan. You can get information directly from the QR code. How to generate QR code? It's simple. You can go to website and like a QR code generator. For example, you want to type something like this is a taste of the Dr.Janchai, whatever, you type on that, and it will generate QR code like this. In my name card like this, I have a picture and QR code. So the people can go to my website, university website, and get more information about myself. And I just came from China a few days ago. It is very interesting. The Chinese students, they don't carry money anymore. They have mobile phone. And then they want to, if they want to pay something, just use QR code or use Alipay or whatever. The Chinese students, they don't carry money. And then the problem is that some beggar came, please give me some money. And they said, oh, I don't have money. Then the beggar has difficulty to get money. How can they do that? Never mind, they have a can. Normally the can used for collecting coins. But they have a can with QR code on that. They can give money by using QR code. This is a real story. It's not a fun, this is not a joke. It's the real story. The beggar in China, they have this one. Very interesting. You see the world is changing because of the IT, because of the world of information technology. And another thing that you can do, you can learn, you can play around with, this is moving picture. Somebody would like to send some kind of stickers to WhatsApp or whatever, you can do. like this. Use GIF animator. GIF is a graphic interchange format. Easily speaking is that you can make a photo, normal photo, put several photos together, and you can get a moving picture like this one. You want to grow seed. First day, and then you pour some water. The second day, the third day, until the fifth day, and you take picture of these 7 days, and put together, you can get the moving picture like that. This is what we call GIF. You can do like this, or you can do like this. You go to website. There are many free websites you can put all your pictures there. I have 3 pictures like this. Or you can do like this. Picture 1, picture 2, picture 3, picture 4, picture 5. Then put them together. Then you can get out like this all the time. Okay, it's very fun. So you can make a sticker. Let me show you this one like this. This what you can do at home, and you can play around your friend using WhatsApp or whatever lines. Now, I'm talking about inspiring science and math at home. Let me just first start with the mathematics, if you like. 9 times table. You can use your finger. You must have 10 fingers, otherwise your calculation will be wrong. Okay, 10 fingers. 9 times 1, you have to put the first finger down, and then you have the rest finger, 9. Okay? 9 times 2, put the second finger down, and you have 2 groups. One is 1 and 8. That is 18. And so on. Okay? Until 10. Okay? Then you have 9 times 10 equals 90. What about if you have 2 digits figure? You don't need your finger from your foot. Just use special technique like this. 2 digits number 26. First you have to separate fingers. 2, separate 2 fingers. Okay. And 6, you have to push down your 6th finger. This is 5, this is 6. And they are 3 groups of numbers, 2, 3, 4. That is the answer. What about 46? You try 46. Separate 4 and push. Yeah, how much? Exactly 414. Yeah, you got it. So we separate 4 and push the 6th finger down. Then we have 414. It's 415. Yes, correct. That is. So this is some technique that you can play around. Another interesting thing is that, have a look at this. 13 or 12 or 13 person? Huh? 12, right? 12, okay. Now you count again. How many people? 13, yes. So 12 or 13 is magic, right? The thing is that you have to cut the paper like this and change the position. Why? You can see 12 people or 13 people. Some smart kids said, we can do something like this. We can put a number on that. We separate 3 pieces of paper, and then we put the number on that. The first group, A, and A red and A green, and down here, just, the whole thing is the blue. Then you can change. Now you can see the combination of different parts. This one, the first man is B1, the second is A6, B2, all different kinds. Some parts of some boys will be a part of other boys. So the total area is equal, but some are shorter, some are longer, and this is a good thing for thinking, the observation. Another thing, it is 64 or 55. We have a square, 8 times 8, 4. Then we just cut this paper into 4 parts and rearrange it into the form of 5 times 13. 5 times 13 is equal 65. So that means 64. Is any mathematics teachers? If you look at it carefully, you see that there's some small space between the lines. The area, of course, yes, the area is 64 area unit. But if you do like this, if you do in a mathematic form, you can see that there's a small gap on that. And this small gap, the area of this small gap is 1. So you have to look at it carefully, and you see, there is something inside. Another one, in daily life, how to fold T-shirt. You can apply mathematics for folding T-shirt like this. This is the way how to fold T-shirt in Japan.
真ん中の上から4分の1のところを左手でつまみます。次に左手でつまんだところから延長した肩と裾のところを右手でつまみます。あとは払って袖のところから折り込むようにして畳めば、そうです、こんなに綺麗にできます。
Oh, it's very fast, right? How to apply mathematics on that? Maybe you look at that once again.
真ん中の上から4分の1のところを左手でつまみます。次に左手でつまんだところから延長した肩と裾のところを右手でつまみます。あとは払って袖のところから折り込むようにして畳めば、そうです、こんなに綺麗にできます。
Now, how to apply mathematics on that? You can apply that. The first thing is that you have to, the length, half of the length, fraction is half of the length, point, and the second one is the shoulder. Just hold the shoulder, touch to the end of the T-shirt, 1/3 of the width. Okay, first thing, half of the length, and the second one, 1/3 of the width. Then put them together. Then you have this, and you have to fold another 1/2. But some people say, oh, it's very complicated. Can you do it easier? Yes, you can do it by using a folding machine. Okay, you have to use a carton, 4 pieces of carton. And put them together like this. And finish. You can fold T-shirt no matter how big or small. You can put into the same size, like this. Okay, you can make it at home if you like. When we talk about folding things, the people think about, oh, folding things must be origami. You know origami? Yes, from where? Originally? From Japan, yes. Let me just show you this one. This picture has been taken 100 years ago. At the time, the Japanese girl, they don't know how to use a high-tech one, just use the simple one, origami. But now, origami is very important. Now, from the simple one, change to this one. And NASA used this origami as origami engineering. Let me just show you this one. And they use this in space.
One of the most important attributes of
More
origami
sound.
is once we have studied and understood the way paper folds and unfolds, we can apply those patterns to things that are very different from paper. I hope by bringing the tools of mathematics into my origami design that I can then fold something that's beautiful and that's unexpected. My name is Robert Lang, and I'm a physicist.
It is very interesting. I got this book from Japan, 43 origami toys. I can give to Prakash to school and you can play around. Let me just show you some example from this book. So that was the example, it's too long, but anyway, I'll just show you how we can play around with this robot toy from Japan, this book, 43 robot paper. If you like, we can do something like a simple glider. We can use a wire, connect to the battery, and then we heat the wire and to cut the styrofoam like this. Okay, we can heat it by using electricity and cut the styrofoam like this. We're going to make a very thin sheets of styrofoam to make a glider. So this is another type of flying paper. You can make a tumbling
How many pages of
paper.
attorney's ads
Use
do
a
you
very
need?
thin paper,
All
like
papers are the same.
from Yellow Pages
Doesn't.
telephone book,
2 pages
very
of
thin
font.
one, and
If using a pattern,
cut into
two
two
strips,
pieces of
take
paper
down the ends,
and fix it together. Then you get these something like this.
cut the sides on the solid lines. Cut the strips apart down the middle. Only then should you cut the solid end lines, which will also separate off the pattern. Whether you use glue or tape to hold the ends together, be very
Then
sparing.
you have two
to keep
pieces
it
of very
level.
thin
For most
paper,
efficient flight, offset the strips.
1 and 1/4 inches
or
offset,
1/4 inch.
like this,
Use a little tape.
and fix together with a sticky tape, the other side, or if you don't like the sticky tape, you can use glue to fix them together. Okay, like this.
Gluing. Put a little on one end, then the other. That's it, but it won't glide well until you can launch deflecting.
The basic principle is that the aerodynamic, the airflow will flow this way and turn the tumbling paper
So too can
like
you
this.
surf lightweight gliders on the
So it will
airwave
rotate like this.
tumblewing. It flies, but tumblewings
Okay.
are contrary. The top goes opposite
Like this,
the
this is
direction
the
of
airflow.
travel because the front is constantly flipping up
And when you move the
to
styrofoam,
fly, the teeth
okay, the air
has
will
to be
flow,
gliding away
and
from
the tumbling
Pinch
paper will,
one piece
will
between
rotate like this.
Thumb and finger, like this, or like this. Either jerk it a tiny bit forward, and or swing the bottom forward a little. Most people start out
Okay.
dramatically throwing it, but it's really just a slight flick. If the glider always turns one way, you're probably unconsciously tilting it. Launch it level. Once you've experimented and figured out how
Or you
wide
can
it
do
should
some other
be,
thing.
and most of your
This way is another simple one. Use the small strip of paper and cut into the figure 8.
This is how you make a spinning ribbon. You can use a piece of paper of any
Piece of
length
thin-
that you like.
Hello? And you just cut
Cut the dotted
in the
lines.
middle and the other 8 in different directions. Then fold them into
Fold
this
it
paper
into
to figure
a
8.
figure 8.
Like that. Then you can try.
Like this.
And then show. Sorry, I need to. Then you need to show it up. Yes.
Okay, let's try it together.
It was in Turkey. It was in Turkey. Another interesting one is the paper glider. What you can do is like this. Use piece of paper like this and cut into two pieces. One is shorter, one is longer. Like this. Okay, shorter and longer. Then you fold it into ring shape. Then you got this one. One in front, one behind, and then you can throw. Oh, that one, it's fun, okay? Like this, you can try at home, yes. And if you throw it nicely, oh, you have to practice more. Anyway, so like this, and I did this in Shanghai, in China. It's very fun. I have also a rocket paper model. Rocket paper model. We can do like this. This is a rocket. We can make into this one, this shape. We have a pump. This is the pump, and the rocket launcher. Then when you push, the rocket will come up like this. Okay, it's also fun. Simple movie. Okay, you can have paper like this. You cut and then you rotate. Look at the mirror like this. You can see the movie. Or you can play around with the soap liquid. You cut the paper in a boat shape. There's a hole inside, and then you drop some soap liquid there. The soap liquid will break the surface tension of water, and you can see the ship will moving. And also this one, if you like, dancing seeds. You put the seeds into the soda water. When you put the seed there, the carbon dioxide dissolved in the soda water will attach to the seed and move the seed up. And when the soda water go out, then the seed will come down like this, dancing up and down, up and down. Or you can play around with fire extinguisher using your baking powder mixed with the vinegar, and you can get the carbon dioxide. Okay, you see the candle, and the flame is gone because of the carbon dioxide. Or another one, you can play around with the smoke ring. Put the smoke into a plastic bottle, and you push the plastic bottle, you can get the ring coming out this way. If you like, this is a more interesting thing. Animal sound. You can use the cup like this. When you were young, you play around with the cup like this, like a telephone, hello, hello, but now you use only one side. And hen sound. If you use this one, you can hear the sound, very similar. You will never know which one is real, which one is not real. Okay. And also this one, if you use 2 cups, you can make it sound like a cat. Okay, this use 2 cups. Okay. It looks like a male and female cats. Okay. So another one is how to make the microscope. The idea was from the Robert Hooke. He made lens from the glass rod, okay, by melting the glass rod, and you can get the glass bead lens like this. When you cut it, and you can get the lens, small lens of the size about the 2 millimeter in the diameter. Use a water bottle. You cut the water bottle like this, and drill a hole and fix the lens there. Then we get this microscope. Put something there like onion cells or feather or whatever you want to see, push over there, and then look, just focus by turning the cap like this. You can see even the water flea. This is the heart. This is what Robert Hooke had seen many years ago. I use a simple one like this. Actually, I have a lot of this. If you like, okay, use the plastic container, fix the lens there, and you can see whatever, onion cell, hair, ball pen, or feather. I put the feather there, and the interesting thing is that you can look against the light and you can see the feather. But if you want to take picture, use the mobile phone, selfie mode. Okay, put the microscope over there and take picture. You can get this. And these are some school student in Bangkok, and the teacher used the iPad to take video of some animals, some insect. Okay, this is the idea of how you can take video from this simple microscope. If you like, is it too fast for you? No? All right. If you like, you make a simple compass by rubbing a needle on the magnet, then the needle become a magnetized needle. Then you put on the paper and floating in on the water. No matter how you turn the plate, the needle will point north and south according to the Earth's magnetic field. Talk about magnetic card. Actually, on the magnetic card, there is magnetic strip. There is a barcode on that, but you cannot see. You can see only the strip, but we can visualize it by using iron fillings. Put it over there like this. Then you can see barcode there like that. But when you want to clean it, don't use magnet to clean it. Okay, it will destroy your information. Use tissue paper to clean it. Otherwise, all the information you have on the card will be gone. Another interesting thing at home, maybe you have a microwave at home. If you read instruction of the microwave, you see that they don't allow you to put the metal inside because it will have what do you call different potential difference. For example, you put for instance, lamp inside, there will be two different potential difference, and you can see the lamp can be on. Not recommend to do that. But if you are eccentric a little bit, okay, just a short while. Okay. And they don't allow you to put raw egg inside. Why? Because the water in the raw egg will absorb, microwave, and boil. No, it's not harmful, but it's difficult to clean. Your mother will, you have to clean it. It's difficult to clean. And also this one, I would like to warn some students, if you want to boil some water using microwave, there will be a process that what we call superheating. The water inside the microwave will be, the temperature is over 100 degrees, but it cannot be boiled and cannot be changed to the vapor until you put some powder like a coffee powder, then you will change the state from liquid to air, like this. When you put some coffee, like this, so it is superheating, so be careful. Many kids, had this accident. Another interesting thing is that Edison, you know Edison? Yeah, he couldn't go to school, normal school, because the people said that, oh, he's retarded. But what he did, he invented a gramophone. I look at his history, his biography, and then I just follow what he did to make the gramophone. I used a plastic cup and use a paper cup, put the needle on that. When I speak on the cup, the needle will vibrate and scratch the cup like that. And then you get the playback. I can hear the sound coming from here. So it's just the principle that Edison did last time. And also this one, I just follow his ideas using a filament. The filament that I use the lead from the pencil and put the 12-volt battery. I can get the lamp like what he did 100 years ago, like that. Okay? And also principle of microfarad electromagnetic induction. I use a pot, normal pot, a metal pot, and use a coil, insulated coil, and also magnet. When they speak on the pot, the magnet will vibrate across the coil, get the electricity. This can be used as a microphone, or if you like, you can use this one also. Use a plastic bag, a plastic cup. Another interesting thing that you can play around at home is the top. The top like this. If the top does not spin, it cannot stand. But if you spin it, it will, like this, it can stand. And if the top tilts a little bit, it will move this way. So let me just show you if you spin the top on earth and tilt a little bit, the top will, what we call precession. According to the gravity, it's basic principle. If we did that in the space, weightless, let me show you this one. I like playing top, okay? If the top does not spin, it cannot stand. With the spin, it can stand. But if the top tilt, it will move like this, okay? If the top stand like this, and if it tilt, it will move this way. But if you do it in the space, it won't be like this because no gravitation. If you study physics, you know that this is what we call precession. And if you like, you can do something like this. Use two pieces of paper, cardboard. Okay? There are two ways to throw the cardboard away. Okay, put them together like this. If you throw it without rotation, without spinning, it's gone. But if you throw it with rotation, just like the top move this way, so it will move this way, so it will come back to you. So you have to throw it correctly, okay? Stand like this, it's about 30 degrees, and use your wrist to spin it like this, okay? Or if you like, I can use balsa wood or bamboo. Okay, move it stronger. I dare not spin it stronger because it will hit somebody's head. But it's guaranteed return. Why guarantee? Because if it hits somebody's head, he will throw it back to you. Okay, the principle is that is used to hard paper and throw this way. Right. Many kids like the flying object. Let me show you who invented the aeroplane. Yeah, brother, right. Yeah, so let me show you this. This is the brother, right? It was in 1903. I show you the history of flying. This movie has been taken more than 100 years ago.